Imagine this. You're standing at the edge of the universe's deepest secret, a place where the laws of physics whisper truths that could shatter everything you know about existence. What if the most powerful machine humanity has ever built didn't just crunch numbers, it started to echo the very heartbeat of the cosmos? In the spring of 2025, as the world celebrated the International Year of Quantum Science and Technology, a groundbreaking fusion of quantum computing and artificial intelligence pushed us closer to unraveling the fabric of reality than ever before. This isn't a tale from science fiction. It's the dawn of a new era where machines simulate the birth of stars, the dance of particles, and perhaps even the origins of consciousness itself. Renowned physicist Michio Kaku, whose lifelong quest through string theory has painted the universe as a symphony of hidden dimensions, has long warned that such tools could reveal a cosmos far more alive and interconnected than we ever imagined. Buckle up, because today we're diving deep into this quantum revolution. By the end, you'll see why Kaku believes we're on the brink of rewriting the rules of reality, and I'll show you how it all connects to the biggest questions of our time. If mind-bending science like this gets your heart racing, hit that subscribe button now and turn on notifications. We explore these cosmic frontiers every week, and you won't want to miss a single revelation. Let's start at the beginning, where the spark of this revolution ignited. Picture a sterile, humming lab in the heart of Europe, not unlike the high-security facilities at CERN or the cutting-edge quantum hubs in Zurich. But this isn't about smashing particles. It's about simulating the impossible. In early 2025, researchers at institutions like IBM and Google Quantum I unveiled advancements that brought us tantalizingly close to modeling the universe at scales we could only dream of before. Take Google's Willow processor, for instance, a quantum chip that achieved a milestone in error-corrected computation, running algorithms that classical supercomputers would take billions of years to solve. This wasn't just a technical flex. It was a door cracked open to the Planck scale, that infinitesimal realm where space and time blur into quantum foam, the smallest measurable units of reality, about 10 to the negative 35 meters across. Now here's where it gets cinematic. Scientists weren't aiming to contact the universe in some mystical sense. That's speculation we'll save for later. Their goal was practical and grounded. Using quantum AI hybrids, teams simulated quantum behaviors in extreme conditions, like the energy distributions in black holes or the early moments after the Big Bang. One standout experiment, detailed in a March 2025 Science Journal paper, used superconducting quantum annealers to generate solutions to the Schrödinger equation with unprecedented accuracy, mimicking how particles entangle and evolve in ways that hint at the universe's foundational code. These machines, leveraging qubits that exist in superposition, being in multiple states at once, processed probabilistic outcomes at speeds defying classical logic. But the real drama unfolded when these simulations spat out patterns that echoed deeper theories. In one case, a quantum AI system, powered by NVIDIA's Q-quantum software on exascale supercomputers like Europe's new Jupiter, modeled lattice gauge theories, mathematical frameworks for fundamental forces like electromagnetism. What emerged wasn't random noise. It was a fractal-like structure, self-similar across scales, reminiscent of the cosmic web of galaxies or the branching of quantum wave functions. Michio Kaku, commenting on these developments in a February 2025 Fox Business interview, called it the closest we've come to a mathematical symphony of the cosmos, drawing parallels to his string theory work, where vibrations in extra dimensions underpin all matter. Fact, these simulations are verifiable. For example, in June 2025, researchers using alkaline earth atoms demonstrated non-abelian lattice gauge theories, advancing our understanding of quantum chromodynamics, the force-binding quarks in protons. No hidden messages here, just raw data confirming predictions from the standard model. Yet, as Kaku noted in his 2023 book, Quantum Supremacy, when AI interprets these patterns, it feels like peering into the universe's source code, a poetic way to describe the elegant equations governing reality. This discovery phase, marked by over 30 major announcements in 2025 alone, from Fujitsu's 256-qubit machine to Microsoft's Majorana 1 chip, signals we're no longer theorizing. We're computing the cosmos. And as we transition smoothly to how these machines are built, you'll see why they're not just tools. They're extensions of our curiosity, probing depths that could redefine existence. If you're hooked already, drop a like below and comment. What blows your mind most about quantum tech so far? Let's keep the conversation going. All right, let's pull back the curtain on what makes these quantum AI systems tick. Think of it like assembling an orchestra where every instrument plays in harmony across infinite possibilities. At its core, quantum computing isn't about faster transistors. It's about harnessing the weirdness of the quantum world, superposition, entanglement, and interference, to solve problems that would otherwise take eons. Start with the hardware. Qubits, the quantum bits, are the stars here. Unlike classical bits that are strictly 0 or 1, qubits can be both simultaneously, thanks to superposition. In 2025, breakthroughs like IBM's Majorana qubits, topological particles that resist errors, pushed coherence times to milliseconds, allowing for more stable computations. Imagine a coin spinning in the air. That's a qubit, representing heads, tails, and everything in between until measured. Entanglement links qubits so that the state of one instantly influences another, no matter the distance. Einstein's spooky action at a distance, now harnessed for parallel processing on steroids. Now layer in AI, quantum AI combines machine learning algorithms with this hardware. Classical AI, like neural networks in ChatGPT, excels at pattern recognition, but chokes on exponential complexity, say simulating molecular interactions for drug discovery. Quantum AI flips that script. Using variational quantum algorithms, these systems optimize parameters in real time. As seen in NVIDIA's partnerships with Google Quantum AI for high-accuracy qubit dynamics simulations in November 2024, scaling into 2025. For cosmology, this means modeling the universe's composition. 5% ordinary matter, 27% dark matter, 68% dark energy, per NASA's latest data from the James Webb Space Telescope. Quantum simulations can probe how dark matter particles might interact at the Planck scale, where gravity and quantum mechanics clash. Michio Kaku ties this to string theory beautifully. In his view, the universe's composition isn't particles, but tiny vibrating strings in 10 or 11 dimensions, most curled up invisibly. Quantum AI helps simulate these extra dimensions, generating patterns that match observed cosmic microwave background radiation. Leftover echoes from the Big Bang, uniform to 1 part in 100,000, as measured by Planck satellite data from 2013, but refined in 2025 analyses. Fact: a February 2025 breakthrough merged digital and analog quantum techniques for universal simulation, modeling complex systems like protein folding or cosmic inflation with 50% fewer resources. Storytelling time. Envision a young physicist in 2025 staring at a screen as the quantum AI renders a 3D map of space-time foam, bubbling fractal eddies at 10 to the negative 35 meters. It's not alive, but it feels dynamic, like the universe breathing. This composition, qubits entangled like cosmic threads, sets the stage for trajectories that could simulate entire galaxies. As we move forward, remember, this tech isn't magic. It's math made manifest, bridging the micro and macro in ways that echo Kaku's vision of a harmonious cosmos. From those foundational blocks, the trajectory of quantum AI in 2025 and beyond is nothing short of explosive. We're not talking incremental upgrades. This is a rocket launch toward practical applications that could transform cosmology and beyond. By mid-2025, the field hit quantum advantage in niches like optimization and simulation, where quantum systems outperform classics for specific tasks. Let's trace the path. Early 2025 saw IBM's $30 billion R&D push, aiming for 100,000 qubit machines by 2030, but with hybrid quantum classical setups already simulating cosmological phenomena. Google's Willow, announced in late 2024 and iterated in 2025, solved random circuit sampling in under 5 minutes, a task estimated at 10 to the 25th years for supercomputers. Trajectory-wise, experts predict 2025 as the pivot to niche commercial products, per the Quantum Insider, with quantum sensors mapping dark matter distributions and AI forecasting cosmic events like supernovae. In cosmology, the arc bends toward grand challenges. Quantum AI could simulate the universe's expansion, incorporating general relativity with quantum effects, something classical computers approximate poorly. Kaku, in an August 2025 interview, highlighted how this could solve Einstein's unfinished equations, potentially unifying gravity with quantum fields. Fact: D-Wave's annealing systems, used by NTT Docomo in August 2025, optimized real-world networks, a taste of cosmological modeling for galaxy formations. But the path isn't linear. Error rates hover at 1 in 1,000 operations, demanding fault-tolerant qubits. NIST's April 2025 superconducting improvements brought us closer, extending circuit depths to 100 gates. Looking ahead, 2026 might see quantum networks linking devices for distributed simulations, per Moody's Trends. Kaku envisions this trajectory leading to digital twins of the universe, where we replay the Big Bang with tweaks to test multiverse theories. Speculation creeps in here. If we simulate alternate realities, do we glimpse parallel universes? That's for implications next, but for now, the trajectory is clear. Steady acceleration toward a quantum-powered understanding of our cosmic journey. Hit pause and think. How might this tech change your daily life? Share in the comments. I'm reading everyone. Now let's explore the shockwaves. The implications of quantum AI in cosmology aren't confined to labs. They ripple into medicine, climate, and philosophy. Practically simulating Planck-scale physics could unlock fusion energy by modeling plasma behaviors, addressing 68% of the universe's dark energy mystery that drives expansion. In 2025, quantum-accelerated AI optimized traffic and EV logistics, per Viva Technology, hinting at cosmic-scale optimizations for space travel. Philosophically, it's profound. Kaku's string theory implies a universe of information where quantum AI reveals hidden symmetries. Implications include panpsychism, the idea that consciousness permeates matter, not as fact, but a speculative lens. Fact: quantum simulations of brain-like neural networks, using tools like PySCF for chemistry, show emergent patterns akin to thought processes. Broader ripples. In defense, quantum hyperspectral analysis enhances satellite imaging for climate monitoring, per FedTech's June 2025 report. For humanity, it means curing diseases. Kaku notes quantum AI could simulate biological experiments digitally, slashing drug development time. Speculatively, if we simulate self-referential systems, it blurs observer and observed, echoing quantum measurement problems. Imagine, every experiment nudges reality, as in the double-slit experiment where observation collapses waves into particles. This isn't alarmist. It's an invitation to wonder what our probes might awaken in the cosmic code. As debates heat up, we'll see how scientists wrestle with these ripples. Stay with me. The quantum AI boom has ignited fierce debates, pitting hard facts against bold theories. Central: simulation hypothesis. Kaku discusses it skeptically, arguing in 2023 that no computer can fully simulate the universe due to infinite complexity, but quantum tools might approximate it. Fact: a 2025 Frontiers paper constrains simulations, showing full Planck-scale rendering of the visible universe is impossible with current physics. Energy requirements exceed the cosmos itself. Debate rages. Is reality a simulation or emergent from quantum laws? Panpsychism versus materialism. Some, inspired by integrated information theory, speculate consciousness is fundamental, like in 1997 entanglement papers. But Kaku cautions, it's philosophy, not proven. Fact: quantum cognition models human decision-making with entanglement, per 2025 Arch reviews, but doesn't prove universal mind. Omega point theory, from Teilhard to Chardin and Tipler, posits universe evolving to infinite intelligence. Quantum AI simulations of converging timelines fuel this, but critics call it untestable. Kaku remains balanced. In August 2025, he said quantum supremacy advances string theory, but doesn't endorse mysticism. Debates at ICQE 2025 highlighted ethical AI in simulations, ensuring no unintended awakenings. These clashes, fact-grounded progress versus speculative horizons, keep science vibrant, pushing us toward truths or tantalizing maybes. Zoom out. Quantum AI's cultural footprint is massive. In media, Kaku's talks inspire films like Interstellar, blending science with wonder. 2025's International Year amplified this. Events like Argonese Quantum 2025 Festival drew millions, sparking public awe. Philosophically, it revives ancient ideas. Heraclitus's flux mirrors quantum uncertainty. Eastern non-duality echoes entanglement. Culturally, debates on simulation theory fuel Reddit threads and books, with Kaku's 2021 piece questioning if we're in a cosmic dream. Society-wise, it democratizes knowledge. Azure's 2025 push for quantum-ready skilling means anyone can experiment. Yet concerns linger. Job shifts from automation, ethical AI use. In pop culture, it's the hero's journey, humanity as cosmic explorers, Kaku as the wise guide. This context enriches the science, making it a shared human story. We've journeyed from quantum sparks to cosmic echoes, grounding facts in 2025's verifiable leaps while dancing with speculations. Quantum AI isn't rewriting reality yet. It's illuminating it, one simulation at a time. Kaku's warning: approach with wisdom, for in decoding the universe, we decode ourselves. This is just the beginning. Subscribe now, comment your wildest theory, and stay tuned. Next, we explore quantum AI simulating alternate histories. What if one change rewrote everything? What do you think? Is the universe a grand simulation or something even more profound? Share below. Let's unravel it together.